Hey everyone, great to be here. So the interesting thing is saying, let's say 1 minute about me. I don't hold anything about data modeling in any kind of titles that I'm using. And the reason for this is like I think I started classically out in the mostly in the product part. So I was doing product for digital products for quite some time, and I always did it in a very how to say data supporting way. And so, but this involves a lot of, let's say, analytical work. So like the classic, what you would today call like analytics things like Google Analytics and then Amplitude. And then, so all the different kind of tools that you usually use. So in the end, tracking events and working with event data was always a very important part of my work. And at some point, the journey ventured on because like front end is nice, but a lot of things are not happening there. And so you want to combine different kind of data. And of course, this then brings you in some kind of data stack. And the first data stacks, like, I don't know, 10 years ago, of course, like were simple, easy, and mostly really like use case driven. And so, but then my journey really ventured on to maybe build bigger data setups, build bigger data stacks, and of course, like the topic of data modeling came into it, but was always like more like a sidetrack. But for me, became now more an important topic because like um, how to say like the different kind of sources that I collect data to work with my clients, and this still like it's a lot of product and growth use cases, and I will showcase this a little bit. Basically now requires me to work more beyond just working within one tool. So really like to get different kind of, let's say, data, a lot of event data, but also like, let's say, batch data from other platforms into a database and then combine it in a good way that I can then enable the different product and growth teams to work with this. And so what I'm doing today, I guess, is a little bit different. So I watched some talks from this meetup before, and also like as a recap and also like an inspiration. And it's often like that people present something that they are doing for quite some time. And what I will show today is definitely not really something that I'm doing for 2 or 3 years. So it's more like it's something which is in my head, which I was trying to figure out for 2 or 3 years, but I'm starting now to develop some ideas how to approach this. And so this today will be a little bit more like an expedition. So where I share my results for hunting for a solution for a specific kind of problem. And Christian was so nice to already give a little bit of context. So like some people were already posting about activity schema on LinkedIn, and it created some uproar and I think some confusion because I don't know, people didn't really know where to put it. And I think sometimes it's hard to see, okay, where are things in the right place? And I'm trying, so when I start this, and this is like a disclaimer, so I start on a very high level because I want to give you my thoughts, my background thoughts, how I see my use case to use activity schema. Maybe this makes it a little bit easier to understand where it can be useful or not. So yeah, this as a disclaimer. So let's get into it. So I'm trying to setting the stage. I mean, this is everyone in this room or virtual room right now would say, yeah, of course, obvious, but this is something that I usually use when I'm talking to people who are just starting out with some data setups. And so in the end, I mean, the interesting thing is like, I mean, we collect a lot of data. So like in the space where I am, I collect a lot of event data, but it could also like batch data from production systems, from other systems that are company using. But I work a lot with startups, and so of course, like a lot of event data is happening. And so we collect the data, then something's happening, and then in the best case, we do some actions based on the data. So in the usual old model, it was always like we create a dashboard. That was the action that was happening with the data. And then we were hoping that when people were looking on this dashboard, they can do some really great things. So this sometimes work out, but often has some problems. And I think the interesting thing, what I really like discovered and where I'm still thinking about is like, I usually see let's say two really high level areas when we look into this kind of, let's say, process from data to action. And so on the one hand, we want to make sure that we store the data that we pull in a meaningful way. A meaningful way means like we don't want to close doors. I think like, I mean, if you look on Data Vault or Anchor Model, it's like, so we want to make sure that on the one hand, we really can make sure that we are flexible enough for any kind of future changes, any kind of different kind of analyzed scenarios. So we want to have as many open doors as possible, and so we don't want to get stuck with, let's say, an approach how we basically store the data after we start to transform it and to normalize it in a way that we can then basically take this kind of data and present it in the way that we need it. So to be as flexible as possible. And so to present the way is for me like the kind of application layer. And I call it specifically application layer for this kind of reason, because like one thing that definitely has changed in the world, like in the projects that I'm doing, maybe because I work more like in these startup use cases and also like more in this product use cases, is like we don't really end up so, of course, like we still do dashboards, and so dashboards are an important part, but what I see more often is like we basically in these projects have a lot of different use cases, maybe not in the beginning. So maybe we start out with, let's say, some basic business performance dashboards. But then, for example, if we look into the area of product analytics, where I basically grew up in, it's like, this is not classic dashboarding and reporting. So this is a lot slicing and dicing the data, often in funnels or cohorts, to figure out what kind of segmentations, what kind of audiences are basically overperformers, which are underperformers, because this is like where you basically then define your growth activities and where you basically say, okay, this is something where I want to invest my next 2 months of product development to improve something. And so the interesting thing about product analytics is like, it's not so much like, how to say, so it's more like an application side. So it's more like, I mean, if I would take it less as a typical analyst, I might open up a notebook and then experiment with some kind of data in there. But product managers usually don't open up notebooks and crunch some data with pandas or with SQL. So they usually need some kind of interface because they're missing let's say the technical backgrounds to do this. And so the other use cases, I mean, like, okay, marketing automation, super interesting use case where I see a lot of more things happening with data that we have in a database, because like we want to enrich marketing activities. And so we don't want to just use the data that is in the CRM system. We want to enrich it. We want to put some event data to it. And so to build these use cases, I think this is like the thing that you now see in all these reverse ETL things and post and so on. So what I want to say is like this application layer, at least in my last 2 or 3 years, I see it broaden up a lot more. And these are just some examples. And so I put this placeholder here at the bottom because I think we will see a lot more of these in the future. And what I discovered is like these different use cases often need the data in a specific kind of shape that I can work with this. And I think this was like my entry level to think about, okay, are there models of data, or is there a way that I can basically model my data that makes it in my use case, makes it easier to do product analytics? Because if I did it in the past, like on a classic star schema, of course it's doable, everything is doable, but it really took time and effort and it made really complex queries in the end to do it. And it was not flexible enough to react on the different kind of use cases. I mean, if I have to build one funnel or one cohort, it's pretty straightforward. But usually the way how product analytics work is like I start with one funnel and then I break it down by different things. And then I look from a different kind of shape. So you basically, you don't have a one clear question where you have one thing that answers it. So usually like you have an idea, and then you have to switch all the different kinds of things. So this is like a reason why product analytics tools are quite popular, because they basically support these kind of things. But I have the motivation to do this on my data that I have in my database, because I can enrich it, which is not so easy in these tools. And so activity schema for me is at the moment, I would call it, for me, is like an application layer. So I could, for example, build it on top of, let's say, a different kind of data model. So right now in the smaller projects, I don't do it because it's not really necessary. But if I would approach these kind of thing on top of a very big, let's say, with a lot of data sources, I can definitely see this like activity schema used besides or on top, let's say, of a data vault model, which is already there, because I really need it, let's say, close to the application that I want to build on top of it. And maybe this is like what also takes a little bit of the of the things that are creating these, let's say, flame war posts. Is like, I don't want to go in there and say, hey, activity schema is now the new data model where you basically build everything around. So I don't see it like this. I never tested it like this, and I don't know, maybe it works a little bit in this way, but maybe it doesn't. So for me, it's more like really like it's a layer that is pretty close to the application that I want to build for the product team. So, and there I need something which gives me a lot of flexibility to create different kind of things. And so this is what I want to show now. Yeah. So what is activity schema? Activity schema in the end has this concept, also not new, that it basically creates one table for an entity, for a business entity. And these tables are pretty small, so it's not like the concept of a big wide table. So it's more like a very small table, very concise, very focused. And it usually uses the same structure for each kind of entity. And so I think in the original one, so activity schema was developed by the founder of narrator.ai based on his experiences where he was struggling with his work when he was, I think, VP of data, or so, like leading the data department at WeWork, because he saw himself like they took a lot of time to basically serve the different growth and product teams to do the kind of analysis they wanted to do. And so in his proposal about the activity schema, so there's a GitHub repository, so there's a link later as well. So when we share the slides, you can see it. He's calling these what I call entity. He called this basically customer, but I don't like the customer terms for that, because like for me it's a little bit misleading. So I more like the term entity. You could also call it object. But the good thing for me is like, so when I define business entity, so what is a business entity? When I, for example, work on event schemas or tracking schemas, which usually is part, let's say 90% of my usual work, is like, I already work in these kind of terms. And so to give you an example, so this, for example, is an example for myself. So I create a lot of content. I create this on LinkedIn, I create it on YouTube and podcasts. So today, for example, is also like something else. So I have different kind of areas, but I have one entity which is called content, and then I have different activities within these entity. And which is good for me is like these activities usually also describe some kind of life cycle. And this is important for me because in the end, I will create funnels about this, and I might also create cohorts about it. Maybe not with content because their cohort doesn't make sense. But for example, when I do customer events, then of course, like a cohort totally makes sense for me. And the good thing is like with activity schema, I basically create a immutable or I think in the data world or a database world, you would maybe impotent model of events. And so I basically just, create a mutable event log focused on this kind of entity. So I have all the activities for content in one kind of table in a kind of immutable event log. And so this is the basic design idea behind that. And so it has this simple single table design. So one thing that I find quite intriguing about this is like we use the same structure for every kind of entity. So we don't basically create it differently. So of course it has some benefits and it has some downsides. So I will come to the benefits and also like the problems a little bit later. But one thing which I already saw by myself was working with this is like it definitely takes, how to say, uh, starting time away. So usually like when I work, for example, on my own data model, it's like I don't do this regularly. So it's not a constant job of myself because like what the things that I do are not so complex that I have to work on it every day. So I usually do it one time a month. And so in other models, I always had the problem that when I was starting to maybe change things or extend things, so I usually took an hour or half an hour to get into this model again. And the nice thing about this one is like it doesn't really take long. So usually I look into it and see, yeah, okay. So because I don't really have to um, basically rethink my initial thinking about it or have to consider some kind of documentation because usually it's always like the same schema. I quite like that it's like this because also like that it's for each entity always like the same kind of schema. This makes also like later writing queries and so on. At some points, it saves you thinking time to do this. And so in the end, what does it have? I mean, it's like what I already described. So it has a unique identifier for each kind of event. Of course, it has a timestamp. Then here you can see it has something like customer, which I call entity. So like in that case, I define, for example, if I do this for customer events, this would be, for example, like the customer ID that I define here, because then I can basically bound all the events for this kind of customer. And I have this all in this table. And then I have the different activities. And the activities can then be like the different kind of events names that I have. So in a customer case, like customer created, customer signed up, a customer logged in, customer authenticated. So whatever I want to track about this kind of customer, or customer ordered a product and so on. And then we have this feature 1, 2, 3. And so I will go a little bit into this, but not too much, because this is, for example, is an area where I'm not 100% sure about the approach. So how activity schema describes is, so they say, okay, we want to keep small tables because they're very performant, they don't cost a lot of money and so on. So what they do is like, okay, we define in feature 1, 2, 3, we define the attributes or the dimensions, dimensional values for these kind of events. And we use something which is called, let's say, feature inheritance. So for example, when I have an event called customer created, I might have 3 features there, for example, like city, email domain. Let's take these 2. And so I don't have to define them later when I have a different customer event. I can then just use an inner join to basically access this different kind of features from the initial created event. And by that, I can basically inherit all the dimensional values from the other events. I'm not super convinced by this approach, at least like, because for me, it really has some problems. So for example, for one thing is definitely like the type. So you usually can just use string there because I mean, it doesn't work anyway because I will place different kind of values in the same column all the time. And so in the end, I cast a lot and it's really nice. And the other problem, I think this is even a bigger problem. You really have to have a good documentation. So if you have, let's say, 15 different activities for this kind of entity, and you place different kind of features here, then it becomes really, let's say, a really like kind of a chaos to look up, okay, what actually is feature 1 for this specific kind of event? So this is the thing that I don't really like. So what I usually do now is like I sometimes use these feature 1, 2, 3 for similar features. So for example, in the content examples, feature 1 for me is always like platform. And so then I know that I basically have the platform there. And then I basically use a dimensional table for this entity, which I then in the end join for final analysis or reporting. So the interesting thing is like how you can work with this. And so this is a very, very simple example. And so it will be simple in any kind of other data structure as well. But so in the end, this is, for example, is an example. So this is like a bike shop. The bike shop, you can buy either day passes or you can subscribe to a yearly pass. And so for this bike shop, it's important to know because the day pass is basically the introduction offer. And so this is a classic growth problem. So like growth teams has introduced this day pass to basically use it as a marketing instrument to get people to use the product. And then, but in the end, they want to get the people on the yearly pass because this is basically like how they grow and how they can make the money. And so, I mean, the first one, two are straightforward. I can just see, okay, how many day passes do I sell and how many yearly passes do I sell over time for a specific kind of months. So the interesting thing is now the growth team wants to know how many day passes do we actually sell to customers before they subscribe to a yearly annual pass. And so this is a common product question. You will see this quite a lot. And what I think basically started, was my starting point to start out with activity schema, because I was trying these things before in different kind of other data structures. And of course, I came to the same results, but the queries were definitely more complex. I had to join more tables to achieve that. And it was not so easy to change it. So I basically developed for one scenario. So like, okay, I want to end up with this kind of event and I want to see which of this kind of event, how often this happens before. So I can create it for one case, but it was then complicated to adapt it to have another event that is the end event and different events. Or maybe I want to have a mix of two different events that are happening before. So this is how I can do this with activity schema. And as you can already see, like it always has the same structure how you do it. So usually this is quite interesting. What I liked about activity schema, and I have another example in a second as well, is like you usually end up with the same structure how you construct these kind of queries. And you can easily put a meta layer on top. So this is also like what when you hear Ahmed talking about activity schema, and they build narrator on top of it. And narrator works so nicely because in the end, it's a meta engine on top of the activity schema. So the questions and the use cases they want to analyze are usually often the same. So they just have to make sure that they just then swap the different kind of information. So for example, here in this case, this is like the final event, like total purchased. No, this is the final event, like subscribe to yearly passes. So I can just swap this, for example, if I now introduce a quarterly pass, for example, or I don't know, a lifetime pass. So I can easily swap these kind of events. And so this makes it a lot easier for me to make to build something for my product managers, for example, using something like retool or so on, where they can configure different kind of things without having to write a query. And so this is something which I really like about it. And so here's like some more examples by my good friend Agast. And so we both discuss our, let's say, approaches to activity schemas a lot. But as I said, we are still like in a very early stage. But he wrote a quite nice post about it, and you will see. So like, whoops, you see the link here. So when we share the slides, I definitely recommend to check it out. And he also has a GitHub repository where he basically published all his queries. And so he was looking in his example in this post, he was looking into classic e-commerce data, and he was analyzing the different kind of temporal relationships. So the one that I showed you before, also like a temporal relationship. So what happens before something else is happening. And so he has this use case, for example, to create a first touch attribution approach. And so here you can see like how this whole query is building up, and it's hard to show these kind of secret queries within a talk. So just take this as, let's say, a first impression, and then later when we share the slides, you can have a, let's say, deeper dive, or I definitely recommend to read a guest post about it. So what we basically do here is like, so first we create a cohort where we say, okay, we want to analyze, let's say when people are ordering something. So this is our base cohort. But what we definitely want to know is like, we want to know what was the first ever session that this kind of customer had, because this is interesting for us when we want to do marketing attribution. So maybe for some reasons, we want to know what was the initial marketing campaign that brought this kind of people in there. And so, and of course you can construct it with other things as well, but here it's pretty quickly constructed. So I just took the different kind of CTEs to show it here. And so these kind of 4 CTEs bring me, let's say, a quick analysis. And here again, what I like about it is like, I can easily go into this kind of query when I have it And I can swap this min statement with the max statement, and the max statement then give me the last touch point attribution. And so, and he showcase in his post how you can do with simple changes to your kind of queries, how you can analyze these different kind of relationships. And this again is like an introduction. And so definitely also like a topic that I want to invest a little bit more time in the future is like to kind of experiment with some kind of meta layer on top of this. So basically use this as a foundation, as a kind of source code, and then put other things on top of it to abstract it a little bit more and to make it more user-friendly, especially like for product people. Okay, so my learning so far, and this is basically now 6-7 months playing around with this kind of approach. So as I already said, like the modeling for this is pretty quick and it can extend really easily. So what I like about it, so for example, in my example with the different kind of content types that I model is for my content analysis. So when I'm started out a new podcast, for me, it's pretty easy to set this up. So I just pull the data from the podcast provider in there, and then I already have a target system that it shows goes into it because I have this content entity table. And then I just add this podcast data in the same way I have already added all the other content data, but then just saying, okay, this basically comes from the podcast platform. So I already have a defined target where I just then pass all the different kind of sources to, which I usually prefer, but I mean, I guess you guys too, because you talk about this a lot already. What I also like is like, at least like in the project that I really at the moment trying out with is like, of course, I don't really have kind of DBT or other kind of orchestration, because in the end, when you see what I have right now, it doesn't really have so many queries to run. And so it's something I can easily run using Prefect, Airflow, or usually in most cases at the moment, because I work on GCP, I just work the workflows engine there. And so it's pretty easy to set up, and I don't read a lot of overhead. And of course, like because I don't run so many queries, I don't create any kind of, let's say, overhead cloud costs to basically model everything in the end. Of course, what I really like is like the model is business based. So when I define these different kind of entities, it's business or product based, depending on what kind of angle I want to analyze the data. And so I design it from the business perspective first. And so, of course, like you are an audience, which I don't have to explain it, but I talked a lot with audience where I have to explain it, because they usually design their model based on the tools they are using or based on the sources they are putting the data from. But here, what I like is like I start to basically model first based on my business. So this is like the entities that I define, or based on my product. And then I define how I get the source data into it. What I really see, and this is what I already say, is like, but I also work with one or two other people on this kind of model. The onboarding is pretty quick. I mean, once you understand how this kind of single table structure looks like, it's pretty easy. So I myself, if I pull up a new project where I worked on some time ago, don't need long, and also other people don't need long to understand it. And then on the right side, let's say the areas to investigate. So right now, this is experimental. For me, it's like I identify batch data. So in my use case, so for example, let's take the content example. When I pull YouTube data, I don't get YouTube raw data, unfortunately. I would love to, but I don't get it. So I just get batch data or aggregated batch data. So what I do right now to fit everything in this kind of model, so I don't have to do it, but I do it right now to learn if it makes sense or not. It's like I basically identify data. So if I have 10 views as a aggregated number, I basically now create 10 events, which say not with a precise timestamp, but I basically create 10 synthetic video viewed events and put them in this kind of table. So I'm not 100% sure about this. So right now it feels okay because it basically fits to the whole structure, but I work with low data volume at the moment, and especially if you work with high data volume, this might not be a good idea. Definitely something to test out. As I already said, this feature 1, 2, 3 approach doesn't really work for me. So I usually, at the moment, I totally avoid it. So I really go back to, let's say, one-dimensional table for one entity, and then handle it as a typical dimensional table. And what definitely was something that was a bit hard for me in the beginning, like the queries take a little bit of rewiring of my brain, because I was not like approaching queries like I would have to approach it within activity schema. So this took me a bit longer. I think for a guest it was a bit quicker because he's deeper into writing queries than I am. But definitely something where it takes some time to get some ideas. I think the good thing is once the pattern are there, then it's pretty quick, but you have to develop the patterns, or you have to wait until other people are developing the patterns and post it somewhere. So is this production ready? Because I was asked this 1 or 2 times. I don't know, so define production ready for me. So as I said, I use this in 2 active projects on, let's say, this application layer design. So I use this on top of an already existing data model to basically speed up the, let's say, the different kind of analysis that, for example, a growth and product team wants to have. And for this use case, 100% production ready, because in the end, what I can achieve with this at the moment is like I can definitely bring results to these kind of questions that these teams have a lot quicker than I had before. So before it took me longer, it was more complicated, it created more problems and also like more data quality issues because we were doing things wrong or joining things wrong. And in this case, we have less problems on this side, and we are definitely much quicker to deliver these kind of things. So if this is a definition for production ready, then yes. Is it a full data model? I guess not. But I mean, this is like the problematic question of production ready. Okay, so this is like the 30-minute introduction and really like highlight on introduction on activity schema. As I said, it's pretty early. Not so many people have played around with it, so I can count them on my hand at the moment, which I know who definitely invested some time into this and to try to figure it out. So it definitely needs more people and more experience to do this, but I like this kind of approach, at least like for my product analytics use cases. And so I will definitely invest more time into this. All right.
Thank you.
Questions, remarks?
Yeah, we have quite a few remarks in the chat, most of them from someone called Jane James, who asks, this sounds like event sourcing, but modified, trying to make it fit for analytics. Is this a perception that you share?
To some degree, yes. I mean, it depends a little bit how you define event sourcing. So if it's like classic CDC, yes, of course, also like a use case, but CDC always has the problem that it usually doesn't use some kind of structured event approach. So it just takes the data how it is in the application database. So I use it a lot like in the classic tracking or measurement or data event collection use cases. So where we collect user interactions from front ends or server responses and actions from the backend side. So yes, but I think it's a fair description.
There's a question from Gabriel Tanasi, who asks, how do you find out how many instances of an entity do exist? Like when you have an activity schema, how do you count customers or products or whatever?
This is the interesting part. In the applications that I do, this usually doesn't matter. So usually like these kind of things, we use the existing data model usually for it. But in the end, I mean, of course, like you can, if you have a good event structure. So for example, I have a customer created event and I have a customer deleted event. So of course I can use these two to basically calculate the total customer number in this kind of case. But it definitely needs a good event structure. So, I mean, my major job is like to provide companies with a good event structure. And I know the problems of not optimal event structures that can definitely create problems there.
Okay, there's another point from Shane. I think you've already partly addressed this, where he says it kind of feels broken to try and produce like an activity schema from a data source that's not event-based, basically, where you have to look at states of source tables and then reverse engineer your events from state changes.
Yes. I would love to live in a, let's say, fully data streaming world because it would like the way how I approach, let's say, analytical things would be a lot easier. But of course, like you don't have it. So, and I don't really have a good answer to this. So as I said, right now I'm just translate them in events, but how to say, it doesn't feel 100% right because like, I mean, in the end, I don't have a clear timestamp. So in some systems, so for example, if I throw these things into ClickHouse, for example, it usually I have trouble because it basically the duplication check that they have built in usually kicks in, and I have really problems and I have to work around this. And so, yeah, right now work around. Not 100% sure how to approach this.
Maybe what could be interesting is I talked to Nikolai Golov of ManyChat, and he will do a presentation about this at next year's Multiscape conference. Where they combine anchor modeling, pretty classic anchor modeling, and the streams tables that almost look the same as the activity schema tables.
Yeah.
And this is something that works very well for them. Nikolai, are you still there? Can you say a few words about this approach?
Yes, I'm here. Can you hear me?
Yeah. Just a few sentences. Yeah. What are you doing there with this combination?
Yes, just like repeating my conversation with a like founder of Narrator, just to forget his name. I also communicated with him. I started asking him, what if I have some complex information about each entity? What if some hierarchy? What if some additional? He says me, it is perfect. It is supported by activity schema. You just have to store them separately around your activity schema. Idea is that activity schema is a perfect approach to do some types of analysis, and I 100% agree with Timo. It really helps a lot because I also do a lot of practical research on my own for product tasks for different ad hoc reports. But if I need to store something complex, I usually create a anchor modeling around it, which greatly like enhances it.
Yeah. Your talk, I mean, I think it was like, I don't know if it was the last one or the one before, was also like was really interesting for me because you basically proved it with your work, what I already had in mind, that you basically have to use different kind of approaches for the different kind of problems. That was really great.
Yeah, we had this in July, I think, and there's also recording. Okay, there's a question from John O'Gorman that I think, John, you have to elaborate on this question because he asks, is this like making event or activity a class that behaves in a similar way to other more familiar object classes? Like, John, what do you have in mind? What other familiar object classes? John, still there?
Oh, hi, just the classic entity model, I guess. Can you hear me?
Yeah.
Yeah, so entities are modeled in a certain, in a certain way. It's a fairly predictable kind of way. It seems like events now, you want to model events in the same way objects are. Just to me, but I'm not an expert in the field. Just had a question on whether you sort of see them in the same light or very similar light.
If you would apply to this kind of pattern, I would say like you basically define event as an object itself, but in the activity schema, like you basically filter it out based on the business entity. So I mean, this is maybe the problem with this term. I mean, of course, the term is already used when you do data modeling. In the end, it's just the event itself is the object, and so then it creates this immutable event table. But what I do in an activity schema is like I split these events up and basically cluster them around, let's take the product example around a product feature. So for example, if I'm a task management, I have a product entity like a task, and then there could be different kind of events happening with this task, can be created, added, updated, whatever. And so then this events are basically the object and this kind of table, but it's filtered down to just have the task events in there, if this makes sense.
Yep. Yeah, okay. Thank you.
There's a question from Petra. Do you have any ideas about activity schema performance? Does this work with like large amounts of data?
So I personally not, because I don't work on big enough data yet. Based on Armin's experience, so maybe like if you want to do a follow-up next year, maybe you can invite him, because like he works definitely on more scenarios there. So he claims that it works perfectly on really high volume things, which I think should be true, because in the end, I mean, you produce very small tables, and I assume that the kind of queries that you run on top of them should run pretty fast, but definitely no tests around that. So it's just an assumption or hypothesis.
Yeah, I think Nikolai has some
True,
good
yeah.
feelings on Snowflake performance. And actually, just a few days ago, we stumbled upon another interesting idea. It seems that the way that Snowflake works, it's not completely a columnar database, but it's a hybrid of row-based and columnar, because basically in each micro partition, you have like a certain amount of rows, and then there's sort of a columnar fashion. And this seems to mean that Snowflake is significantly faster with more narrow tables. And this might also explain why anchor modeling or also activity schema, because like the table is not very wide, perform better than expected on Snowflake. But this is something we have to investigate more thoroughly.
Yeah,
because it
that
goes
would be interesting.
against received wisdom and also against some Snowflake guidance. But if you think about like how the architecture works, and we had some preliminary tests, it could be interesting that like narrow tables perform better on Snowflake.
Yeah.
So Vladimir is asking like, how can non-technical people use the activity schema? Do they have to go through Narrator, or can they create it directly?
If you're really non-technical, Narrator is definitely, I guess, a good way to do. What you can also do is like, I mean, what I see often in my projects is like, I mean, in the end, of course, like it's a design thing. And so the design already starts if you're designing the events that you want to collect. And so if you invest a little bit more into this, that you think in these kind of, let's say, entity activities and then properties around this, already on where you basically collect the events, then you can even do some kind of analysis already in the classic, let's say, product analytics tools like Amplitude, Mixpanel, Postdoc, or whatever. But in this kind of case that I just described, of course, like Narrator is the tool that has invented the idea for activity schema, and it works pretty nicely. And what also works nicely is like how you set it up. So they help you a lot to even take the data, how it is right now, and then transfer it for analysis in some kind of activity schema. So it's definitely worth, if you're interested, to check out the demo with them. So it's quite interesting.
On which kinds of databases or database platforms have you tried out activity schema?
Right now, because I usually test out first on BigQuery, because this is usually where I'm coming from. So just let me see if I already tried out one on Snowflake. No, at the moment, just BigQuery cases.
Okay, so BigQuery. This is interesting for me because I did some data work in BigQuery, and I pretty quickly ran into limitations that BigQuery just refused to parse the query. If I had more than like 2 or 3 analytical functions in the query, it refused it. If I were unioning together more than like 3, 4 things, it refused to parse the query. So I ran into BigQuery like query complexity limitations pretty quickly, and I was wondering if you have experienced something like that with activity schema queries there.
Not so far, but it's interesting. Maybe you should, maybe you should look into this.
Because, for example, I tried to load a business Vault Hub, basically, where the sources weren't like raw data, but already like some kind of business rules. And I couldn't really do this because when I combined more than 2, 3 of the business rules, then BigQuery said, "My query too complex, won't parse."
Interesting.
This is actually why I became an even bigger Snowflake fan than before after this experience.
Yeah, understandable.
Because Snowflake is more like Oracle or like an old school database that might not be like always lightning fast, but at least it parses the query and it gives you a result at some point.
So coming mostly like from these event analyze. So I mean, like the other use case that I usually do on BigQuery is like, okay, let's say the huge event logs that, let's say, front-end interaction can generate. So like from an e-commerce store, pretty easy, like, I don't know, 200 gigs a day. And this usually works, if you handle it in the right way, it works quite nicely in BigQuery. But this is a different approach, so you do different things. So the only thing that you have to make sure is that you narrow it down pretty quickly. So if you don't do, because you will pay a lot of money if you don't do it.
Yeah. There's I think the last question from Shane, who asks, like, what was the key for your experiment here? Were you already working with some kind of system internally that so you could just tie into the application event mechanism to produce this data, or was there some more magic involved from your side?
No, definitely on my side, no magic involved. I think the motivation comes a little bit from this place. So especially in this product analytics or growth analytics use cases, at the moment, everyone is basically going back to the full service tools like Amplitude or so. And I'm not super happy with that, because I know that we already have a lot of, let's say, we can collect a lot of data in the database and we can enrich it already there. And it's super hard to enrich data in these other systems. It's possible to some degree, but not really super flexible. And I always wanted to have, I still want to have a approach to do full-fledged product analytics on top of database data. And that is performant enough. I mean, there's one reason, for example, that Postdoc has decided to move all data still into ClickHouse, because like they were trying their things directly on Snowflake and on BigQuery, and it was just not performant enough. And so there's still a need for a specific kind of model, and then in the case even like for, let's say, some kind of okay, if we can call ClickHouse a caching layer, so some kind of caching layer in between. I mean, ClickHouse also has some optimization for these specific kind of use cases like funnel analysis and so on. Yeah, so I want to have something like this. I think this comes from this kind of motivation that I was investigating into this, and it's far from the end there. So I don't have a solution right now, but I have something that at least gives me the possibility to make things quicker, to deliver the results.
Yeah, Nikolai says that like tens of billions of events in Snowflake isn't the problem. You have to do some, or should do some performance optimizations like right clustering, make sure the pruning works and so on. I think we're almost done. I just want to tie in this to like, I don't know, some kind of like broader trends. Like we see a lot of these modern data stack thingies that come up and then go down again. And I think a lot of them are struggling now because like access to venture capital tightens, because like budgets are about to shrink, because data team headcount is shrinking, because companies have started to like not hire new data people or even fire data people. So I think like developer efficiency, return on investment, stuff like that will become very big over the next 1 to 3 years. And I'm really wondering, I think like my personal hunch is, and maybe you can give your own 2 cents or correct me there, that something like Snowflake, BigQuery, like the Azure data ecosystem around Synapse, probably also Databricks, these things are here to stay, and people will build their stacks around them, but not necessarily use that many other tools or that many other modern data stack pieces. So you need your cloud data platform because you have to scale up and down. You need to store like huge data volumes. You can't do that in a box under your desk. So you need the cloud data platform, and then I think not much else. What do you think?
I think tendency definitely right. I think a lot of, I mean, of course, like there's a VC ecosystem, of course, like this drives a lot of these things because, like, I mean, people making money with this, so of course, like it happens. But it's also like, because I think the problem that you have right now is like it's super complex to serve the different kind of needs that, let's say, a modern organization have with different kind of data. So this is what I was trying to show in the first slides. It's like the use case is going beyond the classic use cases that we had, and I think this is a trend that will definitely continue. So I don't want to bring up data products, which is also like another hype term, but I think it's still a valid term. So in the end, I mean, I did 1 or 2 projects where we really did a custom application for a specific kind of, let's say, product or marketing team. And the power which is within these applications is so immense, because now it's basically like you fit something that people can do their daily jobs better without analyzing something on a dashboard. So it's basically like it fits in their workflows how it is. And I think this will continue. And I think you are right. I think most of the tools around are at the moment like because people trying to solve something quickly that they found. And I think it goes back to the fundamentals where you already post a lot about, and I post a lot about too. So I think the major question in the end comes down to architecture and design, and then building. I think maybe more tools, let's say later in the application state, but not in the first one. And I think cloud warehouses are here to stay. So
yeah. Like you know me, I keep like harping on about deliberate data structure design and metadata driven data warehouse automation. And
but this is maybe another point. This is maybe another point which is interesting, which we maybe will see more. I mean, in the end, it's like if you look on programming language, it's the same. So you start out with some kind of compiler, and then you put more layers on top that basically makes things easier. And this is, I mean, the approach that you write about, like this with this metadata driven, let's say, modeling approach. So I think this is. We will see more of these things. And I mean, this is like why I always wanted to point out this activity schema. So I can put some kind of application stuff on top that is in the end is just generating the queries, and I don't have to write them because
yeah, I think we'll see more and more of this, like first on the data movement, data integration, data creation side. Like basically you don't need ETL tools or ELT tools anymore. You need like an automation framework. Either you buy a tool like Data Vault Builder, like Coalesce, like whatever, or you roll your own. I did a nice experiment for a customer last year where I built my own like Data Vault automation framework on top of Dataform and BigQuery. And if you know what to do, you can build such a framework in a week or so. So I've been involved in like projects before where people started from scratch and they didn't have a lot of experience, and there wasn't a lot of like published material, and it took them years to get to a point where their own framework was running in a good way. But now that we have this experience that we can profit from, it's possible to write your own automation framework on top of something like dbt or Dataform.
I mean, just ask DevOps if you can take away something like Terraform from them or similar things. So they will basically, I think they will cancel their jobs. Because like when you see the power of these like config as code in this kind of thing, which in the end does the same thing. So it creates an abstraction layer. So it does. The whole world, how we work right now in software, would not work with it. And I think this is definitely something that I hope will come to data a lot more, because this will speed up. On the one hand, it speeds up things. On the other hand, which sometimes is forgotten, like it improves quality significantly. So because like if you have configuration,
and like the testing effort also goes down a lot, because if like every insert statement is the same except for like some column names, then you don't have to do a lot of testing.
Don't let people do manual stuff. It usually creates chaos.
But it's very like I think I have to somehow find the end here, but still what is interesting for me, because just earlier today I saw this post from Ergest Reblati. You talked about him, where he said the hidden cost of very elaborate data modeling paradigms is maintenance. There are very few experts who really understand this complicated systems enough to keep them running. Sometimes you have to strike the right balance between useful and maintainable. And I think this misses the point by so much that I'm not even sure how to react to this. This is why I invited some other people to react, because I don't really care about the data modeling paradigm or how elaborate it is. In fact, I kind of welcome the elaborate paradigm, because this means people have already thought about this for some time. What I want is like an abstraction layer on top of that, where I basically define concepts, connections, details about the concepts, and then I don't really care if in the end this generates a data vault or an anchor model or a temporal dimensional model or a regular dimensional model or an activity schema or a combination thereof. I don't really care. I just want to define my concepts, connections, and details in YAML or JSON or some kind of domain-specific language, and then the rest should be generated. And then I don't really care what the exact modeling paradigm is. I don't really care what the exact target data platform is. And I think this point is still something that we can't quite get across, especially towards the Americans. I think like most European data people get this now, most down under, Australia, New Zealand data can get, but the Americans, it's still an uphill battle. I don't know why.
Maybe, I don't know. But so I know, I guess, pretty well. So I think he's just describing the current state. So in current state, in what kind of projects you are, this is what he's describing. What you are describing would be like how to say, the envisioned state where we want to get to. So, and I think this is where we all can agree on. I mean, across,
yeah, but
like
the thing is, like,
Atlantic.
I've been doing stuff like that already, like 5 to 10 years ago. Other people have been doing stuff like this, like 20, 25 years ago. So it's not like it's the future, it's the past, at least for some of us.
Yeah, but the use cases are changing. So, like, I think the requirements are definitely changing to some degree. We can make a second.
But yeah, you need some kind of like extraction layer, some kind of YAML, DSL,
yes,
JSON schema. And I think this hasn't really changed. Okay, maybe it was XML if you go back like 15, 20, 25 years, but I think this
fortunately
is the only real change here.
Yeah. No, 100%.
Yeah, thanks a lot. You've really helped us, because when I first heard about activity schema, I really had a hard time comprehending it and also differentiate like activities schema, the thing from like narrator, the product, and the bus around it. So now I think I really get it. And I think I have written, I think it's in my Substack, yes, a little series on presentation layer paradigms, like historization, modeling, raw information, or whatever. And I think I have to update this to add some more paradigms. Like I already had like flat tables, regular dimension, or temporal dimension. I think I have to add Popini, unified star schema. I have to add activity schema, maybe 1 or 2 more, because really I think right now the differentiation between like the core integration layer, your data vault, anchor vault, whatever, and the presentation layer, your data marts, data interfaces, Kimball, activity schema, whatever, it's still not clear enough. Like you need your like workhouse that like historizes everything, that integrates everything, that just runs and runs and runs, and it's very automated, very pattern based. And then you need like different custom presentation patterns for different use cases. And I think we're still not like unified enough for like the workhouse for the integration, and also not varied enough for the different presentation layer patterns that might have different consumers, different use cases.
Yeah, and I really like on purpose called it the application layer, because I still have struggle at least like for the future world that I see like presentation layer, because presentation was before, but I think now it's changing, because like in the end, when we think in data products, it would be most likely to be the application layer, but also like something we can talk longer.
We can talk about this
what's the right definition for it?
Yeah, and of course, my end game is the model-driven organization, where basically there's just like one giant unified model that basically is the organization, and like the org chart, most of the applications, everything around is basically different implementations of that same model. Like I've started a series of articles on this together with Lars Rönnbeck in my Substack on anchormodeling.com, and we think this is what the end game could be on top of like Snowflake, BigQuery. Maybe even Firebolt. We will see. We hear some more from Firebolt in the future. That's basically there's one technical data platform, whichever it is, that is powerful enough, that is flexible enough. Then there's a single model that's living on it, and where different people on different teams like work on different corners of the model. So it's not like the enterprise data model of old, where like there's one big enterprise data architect who sits there and uses data modeling tool for 5 years, and then the model is already outdated. But it's a living model, like with different people working on it. But this is a huge paradigm shift for most organizations.
I can definitely share the vision. So I definitely see a lot of beauty in the vision. But let's see how it works out.
Yeah, but the thing is, like Lars and I, we both have a mathematical background. Like we're attracted to beauty. Like this is also why we're attracted to this vision. We're attracted to anchor modeling, and the real world is not often that beautiful.
Yeah, I have this dirty economics and computer science background. Maybe this is like polluting the waters a little bit.
Like economics, I don't have an issue with like computer scientists and data. I've had bad experiences with like computer scientists and data management.
But I think this is getting better. So I think we will see a lot more collaboration there. I already see now, so a lot more, let's say, software engineering venturing in this, and a lot more collaboration in this, and like, and because the good thing about, I mean, this maybe it's like some kind of closing, at least my closing thoughts is like, I mean, software had similar problems 10, 15 years ago, and we can look a little bit what they did in the last 10 to 15 years. And I think one of the things that is like really key in software development is definitely the whole race of DevOps and what it basically brought to the table. So like with different kind of things, but mostly like really like deliver, so speed and quality at the same time, where you can, if you want to drill it down, like DevOps, this is like speed and quality at the same time. And if we can get this more and more into data, then I think we have a very nice future.
Yeah, and I think like metadata-driven data warehouse automation is basically our DevOps because it gives you speed, quality, reliability at the same time.
Yeah,
we still have to spread the word here because a lot of times I see this triangle. Yeah, you can get like good and cheap, but not fast and so on. And if you're using like the right kind of automation, this is just not true because it gives you good and cheap and fast at the same time.
Yes. I highly recommend for everyone who, even like when they are not in DevOps, but it can give you kind of idea. There's a book which is called Accelerate, and which basically analyzes the effects of DevOps implementation in companies, and basically I think defines in the end 4 kind of metrics, so you can also like measure it, and they basically showcase how it works, that you can have speed and quality at the same time. So highly recommend this.